Okay, so the open TTS world has just exploded over the past month or so. And this is going to be the first video of at least two or three covering some of these models. In this video, I'm going to go through the new Qwen3-TTS models, and I'm going to talk a little bit about them. We're going to have a play with them in code and see what you can actually do. In the second and third video, I think I'll look at some of the other open TTS models that have come along and perhaps one of the Omni models that I'm finding to be really interesting as well. So jumping in here, Qwen basically announced their TTS way back in June last year. And they've had multiple announcements after that too. So they talked about Qwen3-TTS Flash with multilingual support back in September. They then announced that they were supporting 10 languages, 9 dialects, and 49 timbres in December, followed up by a huge announcement that they were doing voice cloning and voice design. And up until recently, this has been something that really has been limited mostly to OpenAI and Google's Gemini voice models and TTS models. But the big problem with all of these announcements is that these models weren't open. You couldn't just download the model and use it. You basically had to use it through an API with Qwen or one of their providers. That is up until yesterday, when the Qwen team announced Qwen3-TTS family is now open sourced. And this includes both the voice design, the cloning, and generation. So in this video, we'll have a little look at what they've actually got here, but more importantly, we'll have a play with actually using the models. I'll give you a couple of collabs that you can use to actually try out the models, and we'll also look at where you could actually try them out on a Hugging Face Spaces demo so that you can see if there's something you want to use in a project, etc. So first off, looking at what they've actually opened here. There are actually two sizes of the models. There is a 0.6b, which basically has support for a bunch of pre-made voices that you can use in 10 languages that they've got here. You can also use these for streaming. And I gotta say, the thing that for me is really awesome is they released the base model as well as the actual fine-tune model. So if you wanted to actually fine-tune a model for a different voice, you will be able to do that with this base model, so you can actually make a model specifically for your voice. And it would be interesting to see, can you actually take those fine-tuned models and actually tune them for a new language, which I suspect through a few hacks actually may be possible. And I think that's a really good thing. I know, especially when I talk about TTS models, we always get comments from some people rightly saying, this is cool, but it's English, it's not in my particular language or my particular dialect. And so the fact that they've made these base models open, I think really does open up the world of this a lot more. And the fact that they've also made like all the tokenizer and stuff like that open could make it really interesting for training this for other languages as well. So the 0.6b model is the small model. The big model here is the 1.7b model. And I guess we should point out that's still not very big, right? This is still something that you can quite easily run to be able to generate audio. Now, this model has everything that the 0.6 models have, but it also has the ability for instruction control, which you can do to basically do voice designs, meaning that we can describe the voice that we want. If we say, okay, I want a very low, gravelly, hoarse voice, something like that, or we can actually do voice cloning. So if you want to actually clone a voice by passing in a small segment of that, rather than having to fine tune a whole model to do that, we're able to just pass this in and it can extract out a representation of that voice and be able to put it together. So they talk about this in the blog post and their paper as being voice cloning and voice design. And these are features that I really feel up until very recently, with just some of the models coming out now, we haven't really had access to. The debate has always been that all those features are too dangerous. OpenAI and Gemini were very careful about how people could use those features. And even in the past, where we've seen like Qt have a really good model that could actually do some of those features, when they released their open version, they kind of locked it down to a bunch of pre-made voices. So it's great to see Qwen here basically giving us the best of both worlds. We've got some pre-made voices that we can use out of the box, but we've also got the ability to design voices and clone voices. So if we look in here, we can see that the model can actually do things like cloning voices. So if you've got something perhaps in your own voice where you want to be able to speak a language that you can't speak, you can actually get the model to clone your voice and then to render your voice speaking a different language. Another option is the whole element around design of where, okay, we can describe what a voice will be like, and then it can actually generate that voice based on that. Another thing is we can use control of the voice, again, with like a pre-prompt where we can talk about how a particular voice is delivering something and then render it out that way. Then finally, the fourth thing here that this is actually building on is that because you've got the Qwen3 models have been trained already on lots of text and sort of developed a sense of understanding in inverted commas, you can see here that if you put something in perhaps LaTeX or you've got things like an email address, it knows how to pronounce the audio version of those symbols. You don't have to write it out phonetically for the model to be able to do that. And this is where we're seeing the power of their particular tokenizer that they've used and this sort of code book. So often in TTS, you have code books. Once upon a time, it used to be that you would just make out pure phonetics. And this idea of the sort of code books that goes way back. I first started working on training up TTS models about 9 years ago. And this is one of the repos that was really cool back then. Big shout out to R9Y9, who last I heard was working at the Lion Company in Japan. This was an awesome repo of just being able to learn how the Tacotron model worked. This was one of the state-of-the-art models back almost going on 10 years ago now. So while some of these ideas have stuck around, there have been huge changes to the model architectures here and to how these things actually work. Some of the really cool features here is that now this is a fully end-to-end system. In the past, you would train up different parts of the system to get better, and then you would plug and play them together. And people would take sort of one encoder from one model and then patch it with something else or build a sort of next sort of neural network part of it and put it all together. These models nowadays are being trained fully end to end. So you can see here that you end up having something where you've got lots of different tokens, both text tokens, codec tokens, and even thinking tokens and speaker embeddings going into this model to then generate a representation out that can go into the streaming decoder. So Qwen claimed that this model is state-of-the-art on a lot of different benchmarks relating to voice clone and voice design. I'm actually not even sure how you measure these things. Back in the day when I was first doing TTS systems, the big metric used to be this thing called mean opinion score, which basically was just testing, did humans feel like this voice was real or not? I guess in many ways we've gone beyond that, and we're more looking at how can this one model do all these different tasks. So I think the best thing is let's jump into the code, have a play with it, and I'll just walk through some of the things that this model can do, and we can listen to how it actually sounds with the various tasks. All right, so starting up on Hugging Face, we can see there's actually a whole collection of these Qwen3-TTS models. So we've got the base models being the 0.6b base model and the 1.7b model. Then we've also got the two custom voice models. And then we've got the voice design model. So we'll take a look at these, starting out looking at this 0.6b. So this is the small model. It can still do 10 languages, and we've got a number of different voice names in here. And you can see here we've got the actual speaker names, a description of the voice, and then the native language for that voice. And we can see for the Chinese ones in particular, they've got different dialects too, which is cool. Okay, so jumping into the notebook, you basically want to install their package. For this case, I'm using an L4 GPU, but the models actually don't need that much VRAM. We then want to load up the model. You can see this of different sort of speakers that we can explore in here. So you can see here's all the speaker info. Here's a little bit of a description about them, etc. All right, first up, we've got some basic speech to text generation. So let's look at just generating something, and we can say, nice simple one. And this is going to be the speaker Ryan in English. Okay, so this is rendered out. Let's listen to it.
Hello, Welcome to the Qwen3 text-to-speech demonstration. This model can generate natural, expressive speech in multiple languages.
Okay, that's not bad there. If we come down and look at the Chinese example, we can take the Chinese speaker, but get them to speak in English.
Hi there, I can speak English too.
All right, so in some ways they got more of an accent. Let's try this same thing again in German. Okay, so now it's rendered in German.
Hallo, ich kann auch Deutsch sprechen.
And we can see that definitely there are elements of the voice that are coming through each of the languages in here. Let's try doing something with a multi-speaker demo.
The quick brown fox jumps over the lazy dog.
The quick brown fox jumps over the lazy dog.
Okay, so you can see it's quite easy to compare voices and see which one we like, etc. for a project. So I already showed you some of the multilingual stuff, but you can see here, if we actually pick, this is the Ryan one in German.
Guten Morgen. Wie geht es Ihnen heute?
So that's supposed to be the English voice, but speaking in German.
Bonjour. Comment allez-vous aujourd'hui?
French, now Spanish.
Buenos días. ¿Cómo está usted hoy?
Okay, so I'm actually hearing some artifacts in Spanish, so I wonder if that's because of the training data that I've trained it on. And in here, I've also rendered out some of the other ones, Japanese, Korean. I gotta say that like the accents are very good for a lot of them. Maybe not perfect, but still quite good. You can also do things like batch inference. So if you wanted to actually just generate like a whole bunch of different responses that you're going to use, we can just put this sort of into a batch and then generate a batch out. So that will allow you to generate a lot of audio a lot quicker.
Once upon a time, in a small village nestled between rolling hills and
And then you can do things like long form text generation. You can do things like where you can see, okay, how it will actually handle numbers, etc.
The speed of light is approximately 299,792,458 meters per second.
Okay, so not perhaps perfect, but still quite good.
The meeting is scheduled for March 15th, 2025 at 3:30 p.m.
I gotta say that the Ryan voice seems quite lazy at times. And then one of the interesting things you can do too is because it kind of knows what languages it's trained on, it can actually auto guess what language. So this could help with things like code switching, where you've got something where you want to speak most of it in one language, but then have some words in English and then go back. All right, let's go to the next collab where we look at actually doing the voice design and the voice cloning. All right, so this is the collab for the bigger model. So this is, when I say bigger, I'm talking about 1.7B in here. And you can do a lot of the same stuff with this. The big thing that you can do though, is that you can actually start to design voices. So if you look here, we can see we're generating a WAV with a sample rate out, just like before. The difference here is we've got the text that we want it to say, but then we've got an instruction prompt in here. So you can see that this is a young anime voice. And if we listen to it, let me just rewind it.
Hello, everyone! I'm so excited to meet you all!
You can see it's a very cartoon voice. If we try something like this voice, so this is a documentary voice, and you can see that the instruction in here has got a bunch of things in there, including the name David Attenborough, which I'll talk about a bit more in a second. Let's just listen to this.
In the depths of the ocean, where sunlight cannot reach, lies a world of extraordinary creatures.
You can see that that definitely captures it. There's some other ones in here. I'll let you play around with them. The villain one is quite good.
You thought you could escape. How delightfully naive. The game has only just begun.
And you can see here, what I wanted to try was, how well know David Attenborough's voice? So if I put the instruction prompt, just David Attenborough voice, do I get something out?
In the depths of the ocean where sunlight cannot reach.
No, I don't. So this is due to the fact that this probably wasn't trained on David Attenborough's voice. The models, perhaps from OpenAI and Google and a few others, have been trained on enough data that they can actually bring back people's voices, right? So there's enough recordings of someone saying, and this is David Attenborough, and then him talking or something like that, where the models can pick this up. This could be deliberately done on the Qwen team's part to stop that. But it's interesting. So I'd love to hear from people if you've got ideas of like how to get the closest sort of David Attenborough voice. And we probably could fine tune it if we had David Attenborough's permission, of course, to actually get something that was a direct match. Or as you're going to see, we can probably do it with voice cloning. Okay, so you can take the same text, obviously, and generate different voices out.
I can't believe this is actually happening right now.
And we see, okay, that these are starting with size and stuff like that in here. And we can see the actual descriptions there of what's going on. We can do it in other languages. So I've put a demo in here in Chinese, but we could have done it in German or French, any of the different languages that we want to. And then we can also do things like emotions. So where we can basically take the voice. So this is taking the Ryan voice in here, and we can listen to different emotions in it.
I just found out the news about what happened yesterday.
Okay, so obviously the prosody in these is going to be quite good.
Just found out the news about what happened yesterday.
They're probably a little bit over the top, I would say, for these.
I just found out the news about what happened yesterday. I just found out the news about what happened.
And I'll see a neutral one.
I just found out the news about what happened yesterday.
I don't think I'm a huge fan of the Ryan voice in there. And you can do a bunch of different things. So you can do things like whispering, loud, soft, dramatic.
Please be quiet. The baby is sleeping.
Okay, now that one is not super whispering for me.
Please be quiet. The baby is sleeping.
That one's definitely got the prosody right there. And let's just go to dramatic.
Please be quiet. The baby is sleeping.
Okay, so you can see that again, you can do that in different languages going through this, and you can hype these up to actually act out different scenarios and stuff. The part that really blows me away with this is the voice cloning. So if you take the model here and we basically need to put in a sample audio. So I put up a 10-second audio taken from one of the videos. So you can see that it's just talking about video clips and stuff like that. And then what I'm going to do is generate out different audio based on that. So you can hear what my voice sounds like already. The funny thing is actually a lot of people think that some of the videos I've done are done by AI, and they're not. One of the issues that causes that is that we use a noise reduction that for some reason seems to cut off my voice. So this is a noise reduction in Descript. And while I've gotten some better noise reductions, it takes just a lot longer to do the processing of that and then stick it in Descript. So while I'm currently Claude coding my own Descript app, I haven't got around to finishing that. But listen to this. I think this is pretty impressive. The weather today is absolutely beautiful. I think I'll go for a walk in the park. And then this one. This is a demonstration of voice cloning technology. Pretty impressive, right? Okay, so both of those are just cloned my voice, stuck it in there. And you can obviously generate things in batch and stuff like that here. So if we come through and listen to these, first, let me tell you about the basics. Second, we'll dive into the details. Third, we'll look at some examples. Finally, we'll wrap everything up. So for me, this is very impressive as an open source cloning system. It's not totally perfect, but it is pretty damn good at being able to do this. Now, there's a lot of things that you can do where you use a model to make a description of a voice, create that voice, and then just clone that voice. So here we can basically take the voice, create it, and then clone it to actually use this in here.
Young one, you seek knowledge of the ancient arts. Very well.
So while some of the voices might sound a little cliche in here, it's definitely good that you can able to basically take these voice prompts, go through it, and then generate stuff out. So you can see this is basically putting it into the model, and then now we can have it generate.
In my 700 years of existence, I have learned that patience is the greatest virtue.
And at this point, we're actually using the clone of the instruct voice version. And obviously, because we told it what to say and we're able to generate that out, we are able then to use that quite easily here to pass in the text, to pass in the actual voice clone prompt, etc. So if you want to have a play with these, you can come in here and have a play. The Qwen team has also put up a Hugging Face space where you can try this out as well. I don't think you can actually do the voice cloning. Here you can just generate different voices out. But as always, I'll put both of these notebooks in the video description below. So just to wrap up, this is finally out. I've been waiting for this for a while to come out. I did think that eventually they would make it open. And I do think it's just a matter of time before we see MLX versions of this, perhaps even Onyx versions of this, that allow you to run these models on perhaps even smaller versions for on-device or for at the edge, on a phone, that kind of thing. So if you are interested more in how this all works, they've released a paper which seems quite nice. It's got some info on how they trained it, on the data that they trained it. You can see here trained on over 5 million hours of speech data. I'm planning to do another video covering some of the other TTS stuff that's just been released that's also exploding at the moment, and even some of the new sort of Omni model stuff that's out there as well. Anyway, if you've made it to the end, thank you all the way through. Please give it a like, and if you haven't subscribed already, subscribe to make sure that you see the other TTS videos that are coming as well. And as always, I will talk to you in the next video. Bye for now.